Hey Algebra 2 students, this is extra practice for lesson 14. So it should go along with finding our zeros and starting to graph, which is what we're focusing on this week in lesson 14. So this will probably be spend a couple days on lesson 14, that's why it's called lesson 14a. Our objectives are to find the zeros of a function given their factored forms. That's kind of pretty straightforward. As we get more comfortable with it, we're going to spend more time factoring first and then getting the zeros. We also want to be able to identify the graphs of polynomial functions based on their zeros. So that's going to be our big focus today. And here's the standard we're focusing on with this. We need to be able to identify zeros, so just what we're doing in our objective, when factorizations are available, and use those zeros to construct a rough graph. So today we're just matching. Later on this week and throughout lesson 14, we're going to focus on building the graphs ourselves, not just matching them up. Okay, so let's dive right in. Remember, you're going to take notes on this front page. We'll walk through a few examples together, and then on the back side, you have 4 problems to practice, or in this case, just a matching set, and then you can check your answers with the answer key with your intervention teacher. All right. So if we remember, we talked about zeros of functions algebraically already. The zero of a function, it just meant any value of x that made the function equal to 0. So this is what we had focused on back in lessons 11 and then somewhat in 12 and 13. And we found it was very helpful to get the zeros of functions to find values that's equal to 0 when we had factored our function fully. So here we have one linear factor that's all set. It's really easy, ready to go. This other one, this quadratic, we may need to factor it more. So we have 2 options here. With the quadratic, we can either use our box diamond method, or we could just use our quadratic formula to split it up more. Formula. I'm going to use the box diamond method just because I feel like we may need some more practice with that one. The quadratic formula is pretty straightforward. We would just be able to plug it in and get our values out. So to factor this, I'm going to use a box diamond, make my diamond. On top goes the c term times the a term, so -5 times 4x squared. That's going to be get a smaller pen here, that's going to be a -20x squared, because -5 times 4 is -20, and the x squared. And on bottom goes our b term, -8x. So then, to fill in the rest of our diamond, we need numbers that multiply to make 20, multiply to make -20x squared, and add up to -8x. Let's see, factors of 20. There's 1 and 20, or -1 and 20. There's 2 and 10, and 4 and 5. So it looks to me like we need some kind of sum of 8, and it looks like 2 and 10 are the only ones that'll sum to 8. I just got to figure out which one I need to make negative. I need more negatives because we have a negative addition. So +2 and -10, yes, that would add to -8, and that multiplies to -20. So a 2x here, a -10x here. And then I'll make my box really quick. Box is just us figuring out which terms go, which terms multiply. So the first term is going to be our 4x squared, the ax squared term. Last term is going to be -5. And on each of the sides, we put in the terms we filled in. So 2x and -10x. All right. So now I need factors of, I always like to fill in the x ones first. I noticed that like things that multiply to make 4x squared, well, I need 2x and 2x would multiply to make 4x squared. And then if I have those two, I need to get this top right one. Something times 2x gives us -10x. Well, it's got to be a negative, and then 5 would work. That works. And then down on bottom, Negative 5 times what gives us negative 5? Well, that has to be 1, and it should work out for our last term that 2x times 1 does give us 2x. All right, so it looks like our factors, our function all split up. I'm going to rewrite it all split up. F of x equals x minus 1 times 2x minus 5 times 2x plus 1. And those second factors are just from us using the diamond box method. So algebraically, we said to find zeros, it's really nice when our functions split all the way up into factors. Once it's split up into factors, we're just finding values where any one of those is equal to 0. So in this case, it would be places where x minus 1 equals 0, where 2x minus 5 equals 0, and where 2x plus 1 equals 0. All right, the first one's pretty easy to solve. We're just going to add 1. So we're going to get x equals 1. That is a 0 of our function. That's a value of x that when we plug it in to our original function, we'll make it equal 0. For the second one, might have to do this in 2 steps and use a smaller pen. I'm going to go plus 5 first, and I get 2x equals 5, and then I got to divide by 2. So x is going to be in this one 5 divided by 2, or you could think of that as maybe 2.5, 2.5. And the last one, this time I'm going to subtract 1 and then divide by 2. Oops. And this last 0 is going to be x equals negative 1/2. So a couple of things happened here. We noticed we'd like to factor our quadratic to split it up into linear terms. Then they'll be really easy to solve like we did down here. So we came up with 3 zeros, and that's how we did algebraically. So that's kind of a review from last time. Now let's talk about how this looks in a picture on our graph. So we found 3 zeros, and those zeros were places where the function, where f of x, was equal to 0. So looking up here, zeros on a graph are places where f of x equals 0. Well, that's just going to be wherever our y value is 0 on our graph. So remember, my y value, my y-axis is the vertical axis, my x-axis is the horizontal axis. So my y value is places where my function, my blue line here, is going to be touching the x-axis. And I see there's 1, 2, 3 places where that happens. So let's confirm that the zeros we got over here, using algebra, match up with the zeros we see on our graph. Well, this first one looks like it is at, it's halfway between 0 and negative 1, so it's going to be at x equals negative 0.5, or you could say x equals negative 1/2. And yep, sure enough, that's one of the zeros we got on the left side. For the second one, that's right at x equals 1. And the last one is right at x equals 2.5. So really what we're doing in this lesson is connecting that with our factored forms, it matches up to give us the zeros on our graph, and those correspond to the x-intercepts, or the places where our y value are equal to 0. All right, so here's what we want to be able to do today in these examples. It says find the zeros of each function below by factoring. So we're going to be using factoring, and then use them to match the function with its graph. So we have 3 functions here, 1, 2, 3, and we have 3 graphs down below, a, b, c. So our job is going to be first find the zeros of these functions, and then once we know what they are, we should be able to match up our graph with our function. Well, let's look at this first one. So in this first one, I see we have a quadratic, and then we have just another linear term. It kind of got cut off here. I'm just going to rewrite it so we can see it better. And then just a linear term that's happening twice. So I know I want to factor this to find my zeros. I do notice, though, right away that this term, this x minus 2 squared, I can already get zeros from it, and it's going to be it's going to be from the equation x minus 2 equals 0, because it's a linear term, and that would just give us x equals 2. So one of our zeros for this function is going to be x equals 2. Well, looking down at my graph, Graph A has a 0 of x equals 2. Graph B also has a 0 of x equals 2. And graph C also has a 0 of x equals 2. So that one doesn't really help us out very much. So we're going to have to split up our other term to figure out what the other factors are. Again, you could use the quadratic formula here to find the zeros of this quadratic term. You could also just factor it. This one's going to be pretty simple to factor. So we need things that multiply to make 3x squared and add to make 4x. The only factors of 3 are 3 and 1. And then for my box, that's just going to be x squared, 3, 3x, 1, and that's going to be an x, a 3, an x, and a 1. So I just kind of quickly did that diamond box method, and you can pause and slow down and check that out if you want. But that's going to leave us with two terms, x plus 3, x plus 1. All right, so let's solve out these two. Well, this one's going to give me an x equals negative 3, because if I plug a negative 3 plus a 3, that'll give me 0. And this will give me x equals negative 1. So it looks like we found 3 zeros. X equals negative 3, negative 1, and 2. And 2 actually had multiplicity of 2. We'll talk about that more in next lessons, what that means for our graph. But now that we know what our zeros are, let's match it up to the appropriate graph. So it has x of negative 3, a negative 1, and a 2. So it looks like B is the only graph that has all three of those zeros. The others are missing, or actually don't have any of the others same. So graph B would be the correct answer for this one. So at this point, you see what we're doing. You should be able to pause this, figure out how you want to factor this term, get its zeros, and then match up the graphs. So pause that, try it out. Once you have, I'm just going to walk through these very quickly. So you should just be checking yourself or confirming or clarifying anything you needed to as you go. All right, so hopefully you've tried these out. Looking at number 2, I see this is a cubic, x to the third, and there's only one way we've learned how to factor cubics, and that's by grouping. So I'm going to group this one. I see in the first terms between the coefficients, 1 and negative 2, I don't really have any factors in common. But between x cubed and x squared, I have an x squared in common. There's at least an x squared in both of those. So if I factor it out, divide out an x squared, divide out an x squared, I'm just going to have left, I have 3x cubed divided by x squared. That's 3 of them multiplied. Divide out 2 of them leaves me with just an x. And then the x squared divided by x squared, that's just going to turn into 1, and I'll be left with just the negative 2. And so hopefully we get the same factor on the other side. When we look at it, oh, well, yeah, x minus 2 is our other factor, and which is good because I don't have anything in common between x and 1, or I could just say I have just a 1 in common, a positive 1 in common between those two. So if I divide out a 1, I'm left with x minus 2. And then we ungroup one more time. Our common factor now is this x minus 2, x minus 2. So I'm going to pull it out. And what's left over inside is just the x squared after I divide out the x minus 2. So divide those out, they just divide to 1. All that's left is an x squared plus 1. All right. So now we have to figure out values. Now that it's factored down, we got to figure out values that we can set equal to 0. The first one is going to give us one pretty straight up. It's just a linear term. X minus 2 equals 0. That's going to be x equals 2 as one of our factors. Now the second one, we could try and use box diamond method. We could try and use quadratic formula on this. We're going to find, though, that whatever we use, we're going to get stuck, and we're going to run into this kind of problem. Let's just think of it this way. We need values of x plus 1 equal to 0. I need a value of x that when I plug it in and add 1 to it, it gives me 0. But I'm squaring it. So if I plugged in any positive number, I'm going to end up with some positive number plus 1. So it's going to be some positive number. It's never going to go down to 0. Even if I plugged in a negative number for x, if x were negative, I would be squaring it, and that'll make it positive. So say x was like -2 or something. Say x is -2. It would be -2 squared. Well, that's going to be a +4. Plus 1 is going to be 5. So no matter what I plug in here into this second term for the x squared plus 1 equals 0, there are going to be no real solutions from that factor. So that's kind of where you get a dead end. So we should expect to see in this graph there's only one 0 of 2. If I try that out, well, in A we have a second, so we do have a 0 of 2 in A, but we have another 0. We have two other zeros, one at x equals 0 and one at x equals -2. So that doesn't seem right. And then in C, yes, C is a graph that only has one 0 at x equals 2. So that would be graph C that we matched up with. All right, and we've done B already. So now at this point, we expect A to work, but I want to see why it works out. So looking at this one, this may look a little unfamiliar as a type of graph or a type of function we worked with. The only thing that's different about it is there's a common factor of x right away. So if I look between these two, I see an x cubed and an x. Well, they both share an x. So I'm going to pull out an x, kind of like in our grouping method. Divide out x, divide out x. I'll be left with x squared minus 4. So that's just something new I want us to be familiar with, is that sometimes there's a common x and we can pull it out ahead of time. Or maybe a number of x's, maybe like an x squared or an x cubed in common, and we can pull it out first. And then if I take another step to factor this, I should recognize this as a difference of squares. I have a squared term and 4 is a perfect square. And I know that splits into two factors. One of, here my a would be x and b would be 2. I'm trying to make it look like a squared minus b squared. Because x squared would be x squared, yep, and 2 squared would give me 4. So now putting those in, it'll be x plus 2, x minus 2. So from this one, we should expect to get zeros. Each of these parts, each of these factors equals 0. So I can write these equations. X equals 0, x plus 2 equals 0, and x minus 2 equals 0. And if I solve these next two out, x is going to be -2, x is going to be 2. So this should have 3 zeros. And let's confirm that that's what we see in A. Yep, an x at 0, x equals 0 is 0. X is -2, that gives us a 0. And x is +2, that gives us a 0. So that would, of course, be graph A. All right. So at this point, we've seen an example. We should keep in mind our factoring tools. Let's make a little note of them down here. We have difference of squares. We have difference / sum of cubes. And we have our diamond box method for quadratics. And then we also had our grouping method. So look back in your notes for references for those. If you're doing this with your binder, they should be in lesson 12 near the end. We summarized all these, or from the extra practice video on lesson 12 and 13. But on the back, there's 4 functions and 4 graphs. So we're going to follow a similar process. First, factor out our functions, find the zeros, and then use those zeros to match up which graph we're looking at. All right, once you're done with this, check your answers with your intervention teacher, and you are all set to have shown you did some extra practice finding zeros of functions on graphs.